Hello explorers and welcome to another video. It's day 7 of Advent of Code and we are doing another programming problem. And today is they talk about amplifiers. So they have an input signal of 0 and then they amplify that signal through a program over and over and over again to get to the thrusters, and they want a large amount of energy going to the thrusters as possible, but and the different amplifiers have different modes that they should go in from 0 to 4, and there are 5 amplifiers. So I think each amplifier needs only to have one of the modes, so it can only be used once. So you give amplifier A 0 and the input mode, and then amplifier B will have the mode what comes out of A, and then whatever there. And we will use our int computer, and we will use a small program that they supply. So that is what we are going to do, and we're going to find the best sequence with the largest number. And I think also, as we have used the int computer a few times now, I'm going to do some small refactoring and actually create an int computer class. So we will use that in the future and create it over and over again. I think this is something that we won't be not using anymore. I think this is something that we can do some refactoring on because we have used it a lot now. So I will go into some coding and I will be right back after this. And I'm back, and I did a lot of refactoring and I did a lot of checking that my computer still worked with the programs that were possible here. So first up we have all the opcodes. I added the max output variable here. I added a program and input and output, so we have a few arrays for those. and we have an input pointer and an output pointer, so I know how many inputs I have taken and how many outputs I have given, so I can actually give a range of inputs and a range of outputs from this program. And when I create an int computer, I will give it a program and an input array, and I also will create the output with the maximum output array here, and I also have a function to get the output. Then I have this public function run that is pretty much the same program that I had before. The difference is that I will take the input from the input pointer here, this array, and increment that, and the output will be written to the output at the output pointer position, and then I will increase that. So I just moved it over to a separate class to make this implementation a little bit cleaner. Now comes the really dirty things. Because we wanted to try all the modes out, and all the modes needed to be unique for the specific iteration, and we wanted to try every iteration and see what was the largest number through this program. So we have the program up here. I would try to find the largest, and there will be a lot of permutations. I actually used in a site to check how many permutations there were, and there were 120 permutations to actually get this right. And there is probably a good way to do this in a math way, but my way to do it was just to have a for loop and 5 different for loops that I just chained on each other, just to make them smaller. So I put them on one line, so I, J, K, L, and M, and then I will check that each of these are not equal to the other. So M is not equal to K, K is not equal to L, L is not equal to J, and J is not equal to I. And if that's the case, that we have unique values here, I will create a modes array with those, because then I will have one of the permutations, and then I will run this value here, and for each of the modes I will go through and I will run my computer. We'll put the input in here, where the modes will be the first part here. So I will loop through all the modes and add the value to that as well. So the first input will be mode, and the second input will be value. Run through the computer program, run it, and get the first output that I get and put that into val. So I will run through the 5 modes here. And when I've done that, I will have the actual value, and I will check if it's larger than the largest I have come up to so far, and that if not, I will put it into the largest. And then later down here, I will print the largest. So this was the largest value that I got, and this is, what can it be? 24,147,616. So let's see if this is the right value. Not the right answer. Your answer is too high. If you're stuck, make sure that you're using the full input data. Okay. So let's see here. Make sure that I use the full input data. See here. Seems like I did. And K, M, K, L. So I M, L, and all of these goes from 0 to 4, and they should be unique. So let's do a system out here for each of the modes. Arrays to string. Let's see what we get. That this seems reasonable. And no, we have duplicates here. How is this possible? Okay, we need to see that they are not equal to any other of them. Which makes this a little bit frustrating. What's the best way to do that? We could do a set and check that we haven't seen that before. It's a large data structure. So how many if statements will this be actually? Let's see here. It will have 4 for the first one, so we'll check against I, J, and L. And for the next one, which is K, we will have 1 less. So K will check against K, K, K. And the next one we will have 1 less again. And we check L, L. And the last one we will just check I against J. So that should be all that is required to make these uniques. And we get a much smaller value, and this seems more reasonable. So we get 359,142. So let's see if we are on the right track now. Yes! You get a gold star, I get a gold star, everybody gets a gold star! We solved this one. Yes. So I will read part 2 now and figure out what is actually going to be. And I'll be back when I've read it. And I'm back. And this put a little bit of a monkey wrench in my thought process here. It actually is the case that this program that we have here could be run in a different mode, 9, 8, 7, 6, 5, so numbers between 5 and 9, and it will loop through the program multiple times and give multiple outputs that should be used as inputs until it actually stops. So you will first give it an input signal or a mode, and then you will give it a signal in, and then use that input output until it actually gives you a result in the end. And when it halts, you can use that value for the next thruster. So that's interesting. So I need to do some remodeling here, but I still think I can use the most of the things I've done so far. So I'll do some coding and I'll be right back. Hello explorers, and we are back with day 7, and I believe that I actually figured out what was the problem with day 7 and why I didn't get the right result. I've run this now and got 4,374,895. So let's try that on the site and see if that's the right frequency. Yes! You get a gold star! I get a gold star! Everybody gets a gold star! So now we have solved day 7. And this was actually one of those where you go to the Christmas celebration, in the car over to the Christmas celebration. I figured out what was the problem to my int program, and it just hit me, and I haven't been able to think about anything else during the Christmas party. I've been cordial and been nice to the people there, but I had it in the back of my mind the solution all the way. So now we have actually solved it, and I will show you what the problem was. So first up, we have our program up here. We have our 5 int computers. We have the booleans signifying if we are done with a specific loop or not. So it's 1 boolean for each program. And then I have this array that we used earlier in the first example, where we go from, for all the modes, from 5 to 9, so 5 to less than 10. And we only want unique sequences, only 5, 6, 7, 8, 9, for instance. That could be a valid sequence, so we can't reuse the mode. Then we set up the int computer with the program and the different modes, and we give the e value 0 as a starting point. We set all the booleans to false, so we know if we are done, and then we run this while loop, so it will loop through many times until it actually figure out how large this e should be, and we feed the input into computer A, take the output from A into B, output from B into C, output from C into D, output from D into E, and then loop around again. And when we get to the last, when we are exiting the loop, we will take the last result from E, the computer E, and we will see which is the largest one of that. And this was totally fine all along. This was not the problem. The problem was pretty much that I forgot that there is some instances in Java that Java is more like C than any other language. And what's significant with C programming languages, it is that you have pointers to things. You use things by reference, not by value. And one thing that you absolutely use by reference is arrays. So when I created my computer up here, I gave the computer the same program, the same array. It took that reference and stored it in the computer, which means that all the computers were identical. So if something changed in one of it, all the other changed too. So my little change here was just to add this line here, array copy the program into the actual computer. So we will get a fresh array for each computer, so they will work separately. So that was all that was wrong with this solution, and it was because I didn't remember that part of the Java language. If you have struggled with this before, you know the feeling. If you haven't seen this before, well, you learned something today, and I really hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, like puzzles or like different Java libraries or other things that are interesting, then please join the channel. And if you have any comments, suggestions, leave them down in the comment section down below. And I really hope to see you in the next video.